Centuries ago, alchemists set their sights high. They sought infinite wealth and immortality through miraculous transformations of matter. They came up with useful tools and glassware, but not much else. Chemists, on the other hand, set their sights a bit lower and ended up changing the look and feel of the material world, as did our next great discovery. In the 1860s, John Hyatt, a printer and amateur chemist in Albany, New York, made news when he discovered a way to exploit the long, stringy molecules of cellulose found naturally in plants and created the first plastic. 50 years later, Belgium-born chemist Leo Baekeland took the next step in the discovery process.
One of the great pioneers was Leo Baekeland, who made a polymer called bakelite. The usual thing, chance favoring the prepared mind. He was mixing things, but he knew how to explore them. He saw the interesting properties of this.
From two chemicals derived from coal, Baekeland discovered the world's first fully synthetic plastic. And the landscape of the 20th century was forever changed. What exactly is a plastic?
Plastics are polymers. So what are polymers? Polymers are long chain molecules, not individual molecules that are then clumped up into a solid of some sort. They're really molecules that extend out very far. Chains of carbon atoms, sometimes with some other elements in them. So what are the advantages? Well, it's moldable. You can pour it in some liquid form into some mold. Strength? Well, that's not bad. You can make bulletproof vests from plastics. And we've certainly seen that in terms of fibers, they can mimic or even surpass the properties of natural fibers. No fisherman in the world is going to go back to having nets out of cotton, you can bet. Those nets are going to be out of nylon.
So would you say the discovery of plastics is a great discovery?
We have science making polymers, making nylon, making rayon, which has a natural starting point but is modified into a polymer, making plexiglass or polyethylene. Those are the structural materials of our civilization. I think polymers are, in that sense, an example of the human creativity of chemistry. There's just nothing more beautiful than them.
This single gram of black powder costs $500, about 30 times the price of gold. Remarkably, it's a special kind of soot made of molecules called carbon nanotubes. Each nanotube is about 1/1,000,000th of a meter in diameter, thinner than a strand of DNA, yet filled with a world of promise that has a lot of people excited, including a scientist who helped discover them. Richard Smalley is a professor of chemistry at Rice University in Houston, Texas. In 1985, he and fellow chemists Robert Curl and Harold Kroto were studying chemical conditions in outer space. Using sophisticated laser and spectroscopic equipment, they were searching for evidence that might help reveal the chemical nature of interstellar matter. Instead, they found something else, for which they would share the 1996 Nobel Prize for Chemistry. What exactly did you discover?
Well, in 1985, over a period of a week, we discovered that there was one special cluster of carbon atoms that had precisely 60 atoms. That was magic. It was specially stable compared to any other cluster. And we wondered why.
Smalley, Kroto, and Curl named the new molecules buckyballs, after Buckminster Fuller, the architect who designed the geodesic dome. What they'd really discovered was a whole new class of large, all-carbon molecules, which came to be called Fullerenes.
A molecule is not just when some atoms are stuck together by good bonds. There's another property of a molecule, And that is when you put the last atom, it kind of clicks and it's done.
It's stable.
And you offer it another atom and says, no, thanks, I'm happy the way I am. Well, that's what C60 was. We were offering it other carbon atoms in the apparatus we built, and it said, no, I'm going to stay with 60. So here's a molecule. At least it was a molecule in my mind's eye that seemed to explain the results, which has the most symmetry of any molecule ever discovered. It's a big thing. This is about a nanometer in diameter. About 10 angstroms here, a nanometer, a billionth of a meter.
In 1991, the significance of fullerenes gained even more momentum when Sumio Iijima, a scientist at the NEC Corporation, discovered yet another category of the cage-like wonders. But these fullerenes were slightly different. They were made of hollow molecules of pure carbon that formed a seamless hollow tube called carbon nanotubes, or in honor of Smalley's discovery, Bucky tubes. There's Bucky balls, right?
Right.
And then there's Bucky tubes.
Yeah, I've got a, these things get awfully big now. A tube of the diameter of this ball is this big. And this is a fullerene, same sort of structure. You know, here are the pentagons here, and there's the hexagons. There's 6 pentagons here, 6 pentagons there, 12 total. And in between all these hexagons, and now this thing is just a sort of a Bucky capsule, but you can imagine this thing being very long. And in fact, these things have been made millions of times longer than their diameter now. And these objects have incredible properties.
Like what?
Well, for one thing, if you, instead of holding this plastic object, which I can easily rip apart, if you held a Bucky tube in your hands and you go to pull it, you'd find it is the stiffest object in the universe.
Stiffer than steel.
Stiffer than steel.
Stiffer than diamond?
Stiffer than diamond. But you're a big guy, you can pull it. You'd find that you can stretch it out quite a bit before it breaks. And we expect we'll find that it's 100 times stronger than steel in tension. The strongest fiber that you can ever make out of anything, ever. That means like a million years from now, when you ask me what's the strongest thing, same thing. You know, something has to be the strongest of all possible objects. This is it. And it's just carbon, so you could take coal or sewage or old rubber tires and convert them into Bucky tubes. Think what we could do with that. So we could rewire the world. We can make electrical cables that conduct electricity better than copper at 1/6 the weight.
So when you think about this, does it seem too good to be true? Does it seem magical or something?
It does. It does. I mean, how was the chance that you can discover something like this? But that's one of the fascinating things about the current status of our understanding of chemistry and physics. In fact, we can calculate the behavior of things very well these days. The big mystery with Bucky balls in these tubes is not that they would be great if you could make them. It was finding out you could actually make them.
Carbon nanotubes are one of the reasons the word nanotechnology has become so well known. Some are describing it as a modern-day industrial revolution. Nanotechnology refers to building things from scratch, like this nanomotor. It's the ability to assemble the atomic and molecular building blocks of nature to create a new generation of products and applications that are stronger and more precise. Is this the next realm of chemistry? Is this the next thing in chemistry?
I'm glad to see you use the word chemistry about this, because that's really what this is. We can't afford to pick every atom up with our fingers and stick them in. We have to have the atoms self-assemble, and they have to come from some source of cheap atoms so we can make these efficiently. We have a name for that. We call it chemistry. Of course, these days we call it nanotechnology, but it's the same thing. We're after to make a structure of a particular exact form, to do it hundreds of trillions of times a second, low cost with no environmental impact, to give us an object that will allow us to do something technologically that we couldn't otherwise do. Making objects with, if we're really good, the ultimate level of finesse, the way nature has always built the molecules of living cells. We'll now do this everywhere.
So it keeps you coming to work.
Yeah. There's a certain romance about it.
It's taken only 2 centuries to go from a time when atoms were a mere hypothesis to the brink of being able to snap atoms and molecules together and build new technology with fantastic possibilities. And the great discoveries that we've just seen helped make it happen. Exploring beneath the surface of things, inside the realm of chemistry, and changing the world.